Unit 7, Lesson 11, the volume formula for pyramids, cones, and spheres. There are two student outcomes. One is that students use Cavalieri's principle and the cone cross-section theorem to show that a general pyramid or cone has the volume of 1/3 capital B times h, where B is the area of the base and h is the height, by comparing it with a right rectangular pyramid with base area capital B and height h. The second outcome is the volume of a sphere and hemisphere is equal to 4/3 pi r cubed, or for the hemisphere 4/6 pi r cubed, which is 1/2 of 4/3 pi r cubed. Use Cavalieri's principle to explain why a circular cylinder with a base of radius 5 and a height of 10 has the same volume as a square prism with edge lengths 5 radical pi and whose height is also 10. So some important information is that the base of the radius is 5 and a height of 10, and the same volume as a square prism with edge lengths 5 radical pi and height 10 as well. So the reason as to why is that according to Cavalieri's principle, if two figures have equal altitudes, and they do in this case, both the heights are 10, and equal areas for each parallel plane, then their volumes are equal. So we will show that the areas of the cross sections, which is two-dimensional, are the same. So with the cylinder, we're going to look at the base, because the cross section that's parallel to the bases is going to be a circle. The area is pi r squared, and we know that the radius is 5, so it's 25 pi for the circle. And then if we take the square prism, we know that the area of a square is equal to side square, because all sides are equal, and 5 radical pi square is also 25 pi. So that's where our areas are equal, and we have the same height, so we can conclude that their volumes are equal. Okay, some additional vocabulary that you should include in your composition notebook is something called the slant height, and that's the distance measured along a lateral face from the base to the vertex of a pyramid or cone. In the case of a pyramid, the slant height is the height of the triangular lateral face. So as you can see, this serves as a hypotenuse of a right triangle. Because we drop a perpendicular down the middle here, we end up with another leg along the base, and we have this slant height here that serves as the side opposite the right angle, so it's the hypotenuse. The slant height in a cone is right here. Again, drop in altitude, we have another leg here for a right triangle, so the slant height serves as the hypotenuse of a right triangle. In this picture, we have a solid that's called a pyramid, and the volume formula is equal to 1/3 capital B times h. Please keep in mind capital B is the area of the base, and the height h. So find the volume of the pyramid. So we know that's equal to 1/3, and as you can see, it's a rectangular base, so the area is length times width, so that represents capital B times the height of 9. And when you do the math for that, you end up with 228 cubic centimeters. Number 2, if a regular pyramid has a triangular base that is equilateral with sides measuring 4 feet, and its volume is 64 square root of 3 cubic feet, find the height of the pyramid. So this one is a little tougher. We have a triangular base, and it's equilateral with sides measuring 4 feet, and we're given the volume, and we have to find the height. So we know that for a pyramid, volume is equal to 1/3 the area of the base. So the base is a triangular, so that's 1/2 base times height. And this whole thing is multiplied to the height, which is what we're solving for. So now we can fill in some more information. We have 64 radical 3 for the volume, 1/3 times 1/2 base times height of the triangular base times the height of the pyramid. Now this is kind of hard to see, to draw, so I'm going to try to draw a picture to the best of my ability. There's my triangular base. I know that a side, all 3 sides is 4. I'm going to drop a perpendicular, and in an equilateral triangle, when we do that, we divide the opposite side. It bisects the opposite side, so those values are 2. I need the value of this height here, and I have a right triangle, so I'm going to have to find the length of this side using a squared plus b squared equals c squared. So 2 squared plus x squared is equal to 4 squared. X squared is equal to 16 minus 4, and that's equal to 12. And the square root of 12 simplifies to 2 radical 3. So the length of this altitude is 2 radical 3. That's going to go in for the height of the area with a base of 4. So 1/2 times 4 times 2 radical 3 times 1/3 times h is equal to 64 radical 3. So I'm going to multiply these two numbers and get 1/6. I'm going to multiply these two numbers and get 8 radical 3. Bring down the h, bring down 64 radical 3. I'm going to divide out 8 radical 3. So radical 3's cancel out, and 8 goes into 64 8 times. That's equal to 1/6 times h. Cross multiply, and we get 48 is equal to h. Hence, we've solved for the height of the pyramid. The next volume formula is that of a cone, and as you can see in the diagram, you end up with a right triangle when you drop a perpendicular inside. So we have the volume is equal to 1/3 the area of the base, which is capital B, times h, and for a cone it's circular base, so it's pi r squared. And in the exercises for number 1, we're asked to find the volume of the following cone in terms of pi. Okay, I'm going to write the formula. So my radius is 3.2. We need to square that, and my height is 5.8. We get an end product of 19.797 pi. It says to solve this in terms of pi, so we're going to leave pi as the answer, and that is cubic meters. Number 2, if a cone and a cylinder have the same volume and the same height, and the cone has a radius of 9 millimeters, find the radius of the cylinder in simplest radical form. I'm skipping number 2 at this time, and I'm moving on to number 3. So if the slant height of a cone is 26 and the radius of the base is 10, find the volume of the cone to the nearest tenth. So I'm going to take the liberty of drawing a picture of this. The slant height is 26, that's this value right here. I have a radius of 10, so that's this value here. I'm going to use a squared plus b squared equals c squared, the Pythagorean theorem, in order to find the length of the other leg. Now I can plug this all into the volume formula. So volume is equal to 1/3 pi r squared times h. And by the way, these formulas are given to you in the back of the Regents exam as a part of your reference table. So 1/3 times pi times the radius of 10 squared times the height of 24 gives us a final product of 2,513.3. We had to round to the nearest tenths place, so you have to make sure you follow instructions. The volume formula for a sphere is 4/3 pi r cubed, where r is the length of the radius of the sphere. So for exercise number 1, snow globes consist of a glass sphere that is filled with liquid and other contents. If the inside radius of the snow globe is 3 inches, find the approximate volume of the material in cubic inches that can fit inside. So I know that the volume formula is 4/3 pi r cubed, and I'm going to substitute my value of 3 in for the radius. So the volume of the sphere is 36 pi. Number 2, an ice cream cone is 11 centimeters deep and 5 centimeters across the opening of the cone. 2 hemisphere-shaped scoops of ice cream, which also have a diameter of 5 centimeters, are placed on top of the cone. If the ice cream were to melt into the cone, will it overflow? Okay, so here's my cone. That's 11 centimeters deep and 5 centimeters across the opening of the cone. So that's the diameter. Half of that is the radius, so 2.5 is what I need. And I'm going to find the volume of that, which is 1/3 pi r squared times h. So that's 1/3 pi times 2.5 square times 11. And we get a final product of 71.96. And then as for the ice cream that are sphere shape, so that's half of a sphere. We have a volume formula, 4/3 pi r cubed. And I'm going to leave it as a full sphere because two hemispheres make up one full one. And I'm going to use the same radius, 4/3 pi times 2.5 cubed. Gives me a volume of 668.297. So the answer to this question, if the ice cream were to melt into the cone, will it overflow? Most definitely it will overflow. Because the volume capacity of the cone is way less than the volume capacity of the two hemisphere ice cream. Example 1. A cone fits inside a cylinder so that their bases are the same as shown in the diagram below. Calculate the volume that is inside the cylinder but outside of the cone. Give an exact answer. So we're going to have to find the volume of the larger figure, which is the cylinder. And then we're going to find the volume of the cone and subtract the volume of the cone from the volume of the cylinder, since the cone is smaller than the larger figure of the cylinder. And 200 pi is the exact answer. For the volume of the area that is outside the cone but inside the cylinder. Example 2. Gold has a density of 19.32 grams per cubic centimeters. If a square pyramid has a base edge length of 5 centimeters and a height of 6 centimeters and has a mass of 942 grams, is the pyramid in fact solid gold? If it is not, what reasons could explain why it is not? Recall that density can be calculated with the formula density is equal to mass divided by volume. The first thing that I need to do is find the volume of a square pyramid. So I'm going to attempt to draw a picture. So here's my square. Oops. And those are the edges. I have a base edge length of 5. And because it's a square pyramid, all sides are equal in a square. And a height of 6. So that's my perpendicular altitude here. My height is equal to 6. So volume for a pyramid is 1/3 side square times height. So 5 square times 6, and 3 goes into 6 2 times. We have 25 times 2, which is equal to 50 cubic centimeters. So using the density formula for the pyramid, that's equal to mass, which we were given 942, divided by 50, and that's equal to about 18.84. As a result, the pyramid can't be solid gold. Because we were told earlier that gold has a density of 19.32. So this clearly is a value that is less than that. And the reason as to why is that it could be part of the pyramid is hollow, and there is a mixture of metals that could make up the pyramid. So there's a couple different reasons as to why this may be. This concludes the lesson notes, so please complete the homework and have that ready for the next class.